So this is the current page. URL showing the web part, the user name, and then press the button. And then the web browser will then of course show different URL. And then see code and what will be the URL. And this is, roughly speaking, exactly the same question in the diagnostic test. So if you haven't done it, so one of the diagnostic tests in part 2 is about this. And this, of course, again, could be answered if you have understood everything on this line. This one. If you have understood this example, which is of course an example which is shown in week 2, which is actually a bit more complicated than the one in the exam paper. You have 2 input control in this case, and in the exam paper you have only 1. And if you understand that, so you should be able to understand the exam paper section as well. So the answer, of course, is http www.abc.com. Action tells you where the data will be sent to, and then the receiver will be the page. The web browser is loading with post, and post is a relative URL. So then post will be here because relative URL and URL relative to this one. So then we have the absolute part borrowed from the current page, and then so you have data which is transmitted, name in this input control. So you need a query string, start with question mark, and then you need to know what is the name of the data. This is the value of data, which is name. And the name of the data should be defined by one of the attributes. ID is not, class is not, name. Define the name of the data. Of key name. This is the name of the data, and the value of the data is big 1, big N. This is also very similar to the one of the questions in the diagnostic test. So if you still haven't done diagnostic test, so you can go through it. And you see this one actually only have 2 marks. So the answer is really just this URL. If you just put the URL in your answer and nothing else, you get a mark. It's supposed to be very simple. Next one, 2D. What are the 2 mechanisms making the web stateful? What are the main differences between the 2 mechanisms? Okay. Again, this is also about only a single slide. Let's go to example. Weekly is week 4. When in week 4 we learned cookie sessions, if you remember, and at the end of the cookie session we have this. Right? So this question can be best answered by using this single slide, because this is a summary of the whole. 2 things, cookie and sessions, both make the web stateful, period. This, the first part, done, and the differences become stateful. And you will need to remember this. But if you understand, you can use your own word. You don't have to use the same word. Because sometimes when I say understand, which means once you understand, you don't need to copy the wording. Okay. It's that's and it's a skill about understanding, not about remembering. Okay. This is 2D. Okay. So for this one, you probably see already quite a number of sub-questions are a single sign. These are groups. And 2E says, applying the well-foundedness rules to correct the following backward form to XML documents. 5 marks. So, which already said clearly, it even didn't ask you this is well-founded or backward form, it just says this is backward form. So, correct that. And it also says applying the rules to correct that. So which means, yeah, the circle sign, you better also state the rule explicitly rather than just correct it without saying anything about what rules you are using. And, okay, so look at this piece of code, you need to understand that. So the first line looks fun, just XML declaration. Second line, smaller title, sorry, completing Microsoft ER, and then finishing big title, and task. And then you have data type equals to publish, which includes day, month, year, and finish the day in the end task. And it has author, content, my name, and content, something, and then finish off the first and finish content the next. And to correct that, what you need is, of course, XML. When you learn that clear XML, do you remember which means? But of course, after you have the caption of slides, you will see only one. V5, XML, and in here you have actually the XML from these rules. It should be here. So 1, 2, 3, 4. All XML elements have an end task or a self-closing empty element task. Rule 1, have a look. Probably I should write it on board so that we can do the correction correctly, and well, I'm showing the slides of the rules. And if you actually do this work, you probably have to write the rules somewhere. So check. XML portion 0 title something. I will not write the actual stuff. Date, type, to publish, day, month, year, okay, so this is copied badly from the XML. First rule, all the XML elements must have an end tag or self-closing tag. And of course, something is not in the rule is another one. XML tags are case sensitive, which is a rule which we can use to check if XML element is closed. Because case sensitive means title and title, which are not the same tag, right? But it's case sensitive. So this means the first rule, you check title, small one, start. So big one finished, but big one you haven't started yet. So, and then if you look into others, of course, there's no closing tag of smaller title. Basically, this is something that needs to be changed. So, this needs to be changed to smaller. Number 1, okay. One error, and rule 1. Keep checking. Data, date, day, not close. Right? The day is not close. So it needs to be insert. And months, not close. Insert. Months. And year, not close. And keep checking. Author, closed. Content, closed. Okay, finished. So rule 1 finished. So you made 3 changes. So 1A, 1B, 1C, 1D. 3 changes. Second rule, XML elements should be properly nested. So which means something start earlier, need to close later. Title has no child, it's fine. Date has day, month, and year as child. And day, month, and year, which actually you added, which already closed before the date closed, which is fine. And author contains content as child, but also finished earlier and content finished later, which is not properly nested. So swap the two. So you need to close the content first. The content is the child of author, and then close author next. This is rule 2. Rule 3, XML elements must have a single root element as a container of all other elements. So you have title, you have date, you have also which are at the same level, which is wrong. So you need a root. So anything you like is news. Look like news. Okay. So you need to add a root element no matter how you call it. So 3. And the last one, XML attribute value are quoted. No attribute, date has attribute type, and type is not quoted. Right? It's published without quotation mark. Add quotation mark. Or keep looking. No any other attribute type has attribute. Finish. So these are the things which you need to write on paper to answer this question. And the main slide which you need is this one. It will be found in the revision lecture slide as well. Okay. It's clear? So let's move on to the next one. The next one is the last sub-question in this question 2. Explain why XPath is needed in XSLT and what is the counterpart in ZSL. So, if you remember what XPath is, so let's again go back to V6 in this case. XSLT is the main focus of week 6. So this is the big picture of what XSLT is doing. So XSLT takes an input, a source stream, this is input, with is XML, and XML is the tree. You have different elements which actually form a hierarchical structure. And then XSLT will create another tree, which is the result tree, which could be an XML document, could be HTML document. And then Then the question here is, you think about a simple XSLT cell sheet. What you do, you define a template. The template is matched to a particular element of the source tree. You want to handle the root element, you want to handle something inside the root element. And then inside the template, you say you want to output this value, the content of a particular element. And then you will probably create a HTML of these pointers or XML. And then those things match against what? Match the element, the template to a particular node of the source tree. For each, select a particular number of elements of the source tree and do something with that. Value of, select the content of a particular element, get the content. So, and those things, this one, and these two, which are values of match and select, these are XPath expressions. So the XPath tells you what elements or what nodes of the software you want to use, such that you will convert, you will transform the source tree to actual result. So it's needed, of course. Without that, you don't know what part of the software you want to do the transformation. So, in other words, if you want to make it closer to the term of CSS, you can see XPath. This is how you start writing. XPath allows XSLT to do something like this with selected number parts of the, you can see, you can use a standard from source tree, or you can also say input XML element, which will be the same. The keyword here, select part of the source tree. So this short sentence roughly will do the work. And then the question has, of course, also asked why it's needed. Without that, you don't know. I mean, this sentence should be sufficient to tell you why you need that, but you probably need to rephrase it. It's needed because XPath is needed. It's needed because it allows. If you rephrase this way, it's probably more match more to the question. It's needed because it allows XPath to do something with selected part or for the selected part. I remember of the source tree, and you can also say to produce the source tree. The result or the output. But how you, so it's no hard rule, but how you really phrase your answer as long as you actually count keyword actually selected part of the source tree, which is and counterpart in CSS. Anybody can answer? What XPath corresponds to in CSS? If you have to do it now. I'm not sure if I highlighted this part during lecture from the beginning. So XPath allows you to select part of the source tree to do something.
Is it ID?
ID?
Yeah.
What do you mean ID? CSS ID or
I might be wrong.
other answers?
Is it on the selectors?
Yes. Because the keyword select, and remember what CSS selector is doing. selector. Selector allows CSS to take some elements of the HTML document and apply properties, which is very similar to XFD. Of course, they are working in a different way, but in terms of selecting part of the thing, and it does the same. But of course, for the answer, you only need to see selector here, so it does not say why it's counterpart, just a what is counterpart. So, if you want to repeat a similar sentence for CSS, so XPath for XML, for XSLT, XPath allows XSLT to do something for part of the source tree and to produce the result tree. For CSS selector allows web browser to select part of the current HTML documents to apply the style which you define. You have only one document, but you have different style, which is probably a little bit tricky. So these are the 6 sub-questions in question 2. So the number of sub-questions, of course, is not fixed. This means although you see 5 in previous year, it doesn't mean you will have 5 sub-questions this year, because it actually depends on some sub-questions will be larger, have more marks, and some will have less. So finally, in total, there will be 25. But it will be normally 4 to 6, no less, no more. Normally, 4 to 6 sub-questions.
So far, okay.
Huh?
So far.
What? Oh.
You hear the alarm?
Why are you quick? It's somewhere else. Not in this building. Because otherwise it should be very loud in here rather than. So otherwise it fails. Okay, so and regarding question 2 in general. So and you see that this is more toward the practical part, coding, particularly understanding code, explaining how the programming base works, how the different parts of the program works. And so it's not purely about if you know how to write a piece of code, because for XSLT, for instance, you probably already noticed in coursework 1, it's pretty easy if you copy the example and apply it to your own XML documents, and you just change a little bit. You don't even have to have a very in-depth understanding of what really is going on there. But in here, of course, you need to then have a little more understanding of working. Okay. So, no more questions. Should we move on to question 3 and question 4? And question 3, let's probably look a bit intimidating. So, what actually you probably I'm trying to simplify this, but it's probably a bit big context. So I tell you why you have a big sentence, a big paragraph over there. So I read the first paragraph first. This question tests your capability of modeling data of a real-world application using the framework and terms in ER model as the first step of designing a database. So, and the next paragraph, which is quite big, which just gave you the real-world application and explaining different parts of it. So, and what it's actually really about is talk about, if you read the first sentence, reduce that. Okay, it seems to be the largest one. So imagine you are asked to model the data of a website for the Department of Computing to manage research projects, awarded to academic staff. So if you don't read other sentences, so these sentences will be basically the main thing which you need to think about. So I will remove those. So let's temporarily skip the other sentences. So the first sentence tells you what is the application. So research projects awarded to academic staff. this is application, which means something. So the trick of reading this is if you see the first sentence which is clear about the application, so you can skip to other two questions. So if you look at the sub-questions, the sub-question A, so in addition to research projects, list at least 6 other entity types that are essential for the application. So because we are talking about ER and ER modeling, so of course we are talking about entity types, or entities, entity types, and relationships, these kind of things. So the question 3A talks about, you have already one entity type which is given, because you are talking about project, research project awarded to academic staff. Right, you have research project, which is the entity type which is given. Can you list more entity types? And then which of course require reading further. Then if you read further, a project has a title which looks like talking about something. Each research project must have one and only one principal investigator, but possibly a number of co-investigators. The PI and co-Is, principal investigator and co-investigators, may come from different units, not limited to academic departments, or even different research institutes in the UK or abroad. Each project has at least one founder and a number of co-founders. The projects may also have one or more research partners from the public or private sectors. A founder itself may be a research partner. For instance, the company could fund the project but be involved as a partner of another project. A founder may also be a person rather than an organization, which means if you are rich, you are a billionaire, and you can invest money as a person to the department, to a particular person, and say you become a person. And it further says a project can have research assistants who can be either a member of research staff, for instance, postdoc fellows, or a research student. A research project can be an extension of another project or part of a big project. So it's based more reading. As I said, I try to reduce the amount of reading for this year. Hopefully it won't be too little, but because you need to have proper content. So while I was reading, have you noticed what are the entities which actually you something hate your while I was reading? So you have a research project which is without problem because this is about the research projects as the center. Could you tell me 6? I would like you to do it. What? Oh. You mean principal investigators be another entity types? Okay, so let's temporarily write this down. So how you are going to call it? You call it investigator or you call it how you call it?
Pardon?
How you call it? You call it PI or you call it co-I or you call it investigator? Oh. Investigator. Okay. Anything else? It's hard. Oh, entities. Think about entities. What are the entities which actually appear in this paragraph?
Academic staff.
Huh? Academic staff? Academic staff. Continue, please. Yeah, and? Try to identify nouns, basically. Nouns from the paragraph. which actually describes some kind of stuff, some objects. Other nouns? Yeah? Founder. Okay. Continue. You still have at least 3 to go. A, you have the current 3 are all correct. What? Co-investigator, you mean? But you will have investigator already, so you want another co-investigator. Okay, so write it closer to the investigator. O-I. Okay. Yeah. Research Institute. Good. Research Institute. Let's use RI. Research Institute. And further?
Department.
What?
Department.
Department. Okay. Department. Continue. 1, 2, 3. You have 3 already. I have 6 already. So if they are all correct, you can stop. But I will tell you that they are not all correct, so I need more. Huh? At least 6. But of course, if you have 12, for instance, and 6 are correct and 6 are wrong, you will get 0. Because you cannot just randomly write as many as you want and then in the hope that because you can list everything, every noun which will give you the right answer. In any case, it doesn't make sense, right? More. So may I, let me see which sentence. So let me read another sentence. The PI and its co-I's may come from different units, bracket, not limited to academic departments. Does this figure some? Okay, let me read another one. A founder may also be a person rather than an organization. This sentence contains 3 nouns. Which ones are covered? Which ones are not covered yet?
That's an organization.
Okay, good. Okay, so if I tell you that co-I, investigators, and founders are better known to model as entity types, then you have 1, 2, 3, 4, 5 left. So you need 1 more at least. So I will explain why these 3 are better. I say better, which means if you write it down and if you argue it to convince me, it's possible. But it's possible for founder. It's less possible for investigator. I will explain later. Anything more? Okay, I write down the sentence. So a project can have research assistants who can be either a member of research staff, or a research student.
Research staff, research student.
Okay. Research student, research staff. Okay, so this gave us 7. So yeah, may I add more just to see that you actually have more choices rather than just one of these ones. So it says PI and co-I may come from different units, and you have academic, you have departments over there, but you also have non-academic departments, which is covered. You have units, right? And you have research institute already, and founder. You have organization, you have person, and research student. It's largely like that, but of course, because you have academic staff, you have research staff, of course you can also have staff, right? Because you have two different types of staff already. The staff is also something essential sometimes. And these largely actually give you something to select from, the six, if you want. And okay, let's move on to 3B. 3B asks, what attributes does a research project have? Pay special attention to the difference. Okay, so I will explain those three later on when we reach the relationship. Okay. So relationship is C. B, B is about attributes. What attributes does a research project have? Pay special attention to the differences between attributes and the relationships. And do not include attributes that are better modeled by relationships. So research projects. Research project is something given. So what are the attributes for research projects? Which sentence actually gave you largely the answer? Which sentence?
Research project must have one knowing one PI.
So you mean PI is the attribute. So now we have proposal about PI and co-ice should be anti-ice. Now we have also proposal about this should be attributes. Okay. Which is actually that's the PI and co-ice. Co-I multi-value, right? Because you have multiple. Another sentence? Any other sentence actually give you at least the other part of the answer? Yeah. How many attributes you can get out of that? 1, 2, 3, 4. Right. Title, summary, duration, and founding amount. Okay. So yes. Actually, the second question tells you actually the answer. And then, of course, there's also the remaining question regarding principal investigator and co-investigators, how we choose model. So this is probably often the most confusing part, or difficult part. Something look like attributes, or look like entity types, but they are probably not. They are relationships. Let's move on to the 3C. 3C lists 8 binary relationships between any two entity types. So then here I will then convert the founder, investigator, and co-ice to relationship. And you can judge if this model is better than having them as entity types or attributes. Not good as attributes. Relationships. Yeah, please suggest and relationships. 1. So I think I will finish this one. So I let you go at 10 to 11. So we have another revision lecture at least, right? For the idea at least. And then for the other, you can check the solution. So please list some binary relationships among any of those two entity types. Or let's ask this question. Can you model principal investigator as a relationship? Principal investigator as a relationship. Between which entity types? Who can be principal investigator? academic staff is a PI of, right, research project. B. One relationship, binary. Is this better than entity type? So, because one academic could be PI of multiple projects. So if you model it as entity type, you will be in trouble at some point, because and one academic could be PI of no any projects.
Can PI be an associative entity?
Associative entity still need another entity type, because associative entity is a relationship. What is the other side? You first need a relationship, then you can have associative entity. Okay. The other one, co-I, we just copied that. Academic staff is a co-I of a research project. Because one research academic staff can be a research project, and research project can have multiple co-Is. 3. Any more? Founder. Could you also describe founder relationship? Who can be founder? A founder may be a project may have one more. Each project have at least one founder or a number of co-founders. Is this a relationship? Okay. A person, and also remember, founder could be a person. A person is a co-founder of a project. 4. An organization is a co-founder of a project. Because the founder could be a person and organization. And then this relationship makes it a founder. The founder is actually also a relationship. It's better to model as a relationship rather than entity type. Because this is a relationship between something and something. And of course, further, you can make the relationship associative type, entity type, because it looks like entity type as well. And 4, you can have more research staff. Research student is research assistant of a research project. And you can also have research staff, right? Is RA of a project. And you also see partners, right? You can also have partners. So an organization is a partner of a research project, which is probably too low. And then you also have relationships. The PI and co-Is may come from different units. An academic staff belongs to a department. If you have that, you have 8. A department is part of a unit. It's kind of unit, which is actually supertype and subtype relationship. Okay, I think I should stop here.